Hi YouTube. In this tutorial, I'll show you guys how to create a simple ARP scanner in Python. So this will probably be a 5 to 6 part series. By the end of this series, you'll get the full script. So I will quickly explain what this script will do. So this script will first, you will pass it your IP address, your interface, network interface name, which in my case, it will probably be ETH0. So it will find the IP address of the interface. Once it found the IP address and the subnet mask, then it will send ARP requests, and by sending those ARP requests, it will discover all the hosts in the network that respond to these ARP requests. So it will show you the IP address of the host and their corresponding MAC addresses. This will be our script. This will be the end product. So for the first part in here, the first thing that we have to do is we have to import Scapy. Now Scapy is a powerful library for network packet manipulation. It lets us interact with different network protocols directly from our Python code. Now if you want more information about this, you can go to its documentation. The first thing we have to do is we have to import it. So from scapy.all import, you will import everything. This will be faster this way. So once we do that, the first thing we have to do is we have to create the ARP request packet. So let's say ARP request. Once we do that, let's create the packet. So it will take a destination. For the destination, I will type the IP address, which for me, for a target that we will be doing for this practice, it will be 187. Sorry. So this in here, ARP, this is the ARP request. This creates the ARP layer, the ARP packet. It takes different arguments. For now being, you'll just give it the IP address, which in this, for our example, it will be the IP address of a host connected to my network. It's 192.168.1.187. The next thing we have to do is we have to create the Ethernet frame. So the Ethernet frame is used to deliver the ARP request to every device on the local network. So for that, let's quickly create that. Its destination, the Ethernet frame's destination, will be the broadcast address, which for us it will be FFFFF in here. So what it will do is it will send this request, this ARP request, to all the hosts or nodes on the network. It will send it to all the networks, to all the hosts in the network, and the one that has the IP address of 192.168.1.187, it will respond back to us. Next, what we have to do is we have to combine these two layers. Now this is what will be sent to the entire network. So let's quickly create this. ARP broadcast request is equal to, we create first, we will type in the broadcast in here. Then we this is the broadcast, this is the Ethernet frame. We will follow it with the ARP request. Again, if you have any question about ARPs or this Ethernet frame, just type your question in the comment section and I will try to answer it. ARP request. So now that the packet is formed, our next goal is to send the packet. So we will send it using another function from Scapy. The function is SRP. So let's quickly create that. So we will call it answered list, and this SRP function will send our packet, our Ethernet packet or Ethernet frame to the network. So the first argument that this will take is the broadcast request, which in this case is in here. It's ARP broadcast request. This is the first argument. After the first argument, then we will specify the timeout. The timeout, what it means is it will wait for how many seconds do you want it to wait before it moves on. So for us, it will be 1 second. We will use a timeout of 1 second. It means that it will wait for 1 second before moving on. Then we have to specify the verbosity. For us, we don't want the output to be very verbose, so we'll just type in false. We don't want it to be verbose. Now this will send us two things. So let me just quickly type this. So the first list is a list of successfully answered packets. So if we type a 0 here, we will get a list of the packets that were successfully answered. But if we type in 1, then it will send us a list of packets that were not successful. But we want the successful ones, so for that we want the first list. Then we have to loop through that list. So we will go sent and received and answered list. So in here we will say show us the sent packets and also show us the received packets. So in here it will loop through the list. In here it will show us the packet that we sent and the packet that we receive from this host in here, if this host exists on the network. So let's go to the terminal. In here, this is our script. So if we say Python 01, we run it. It says operation is not permitted. So we have to run it with sudo level privileges. Once we do that, okay. I hope you guys can see this. So in here, you can see that the first thing we did was we specified the ARP packet and also the Ethernet frame. So this is the first one is our ARP. This is our ARP packet, and the second one is the Ethernet frame. So let's start with the ARP. In the ARP, we only specified the destination, which is 192.168.1.187. So this is the first packet, the first one that is sent. In here we can see this, the sent one. It's printing the sent. So we see the IP address. So this is the PDSD. You can see this in here also, PDSD. So we only defined the PDSD. It is the destination. The destination is 192.168.1.187. The source, PSRC, it is the source. It's my IP address. It's 192.168.1.192. This is the IP address of my computer, my host. This is my MAC address, HW source. It's the hardware MAC address. Now this is important here. If you look at this OP, it says who has. So this ARP packet, it tries to discover hosts, which in this case we are trying to discover the host 192.168.1.187. So the ARP, the type of the ARP request is a who has this IP address. Then let's move to the Ethernet frame. The type of the Ethernet frame, that it takes an ARP packet. It again, you can see that it specifies our MAC address, which in this case they are both the same. This is my MAC address, and then this is the destination, which we can see. This is the broadcast Ethernet frame, which is FF. It sends it to all devices in the local network. Now this is what we sent. So what we received. So again, what's received? Let's look at the ARP first. So in here we can see that the first one was we were first printing the sent, and this is the received one that we received. This port, second port, is the one that we received. So in here we can see that this time the source, this is the source in here, 192.168.1.187. So this is the host that you're trying to discover. It has responded to us. This is its MAC address. So it has sent, this time, you see, last time the PDSD, the destination was 192.168.1.187. This is what you're trying to discover. So this time, the destination is 192.168.1.192. This is our IP address. This in here p source, this in here it shows it at 192.168.1.192. In here it's the source because we were sending this Ethernet frame. So the one that we have received, the ARP packet, this time it's reversed. The destination 192.168.1.92, and the source is this, and this is my MAC address, this 78. In here you can see that it's the source. Now the important part, it's the OP. The OP here is at, you can see it here. So the last time we checked the packet, the ARP request that we sent, it had the OP of who has. The response that we have received, the OP, it is at. So our request was who has this IP address of 192.168.1.87. What we have received, it's 192.168.1.87 is at. So this is the network. It gives us the IP address and the MAC address. Who has, it's what we have sent, is at, is what we have received. So we said who has 192.168.1.187. This is what we were trying to find. This is at response that says that this is this IP address is with corresponding to this MAC address. So this is it for this tutorial, guys. In the next tutorial, I will bring further improvements in this script, and this will probably be a 5 to 6 part series. And if you liked it, please do like and share it. And if you want more tutorials, please leave your comments below and don't forget to subscribe. Thank you. Hi YouTube, welcome to the second part of the ARP Scanner tutorial. In this tutorial we will see how to refine the information that we get. So right now when we run this scan, we get lots of output. We don't want all of that, it's not necessary. So in here if I type Python and if I run this, it will give me a lot of output. So we don't need all that. So all we need is for the received part. So the first one, as I explained in the last tutorial, the first part, this is the request that we sent, this part, and the second one, it's what we receive. So what we are interested in receiving when we receive the packet, what you're interested in is the hardware address and the IP address. So the source, and this is the source. So you're sending a request to 192.168.1.187, and this is the hardware address. This is what we are interested in. This is what we want to receive. So in this tutorial, we will see how we get that. So for this, what we have to do is let me drag this down. We don't need all this space. So I don't need these two lines. So in here, if I print, so what do I want to print? I want to print the IP address. So I can say IP, and for the received, I want the source and the MAC address also. So I want the source IP address and the source MAC address. So received source. So what it will do is it will look at the received packet. It will take the P source and HW source, which is the IP address and the MAC address. So this should be the MAC address that we receive. Start with 08 and end with 78. Sorry, not that one. Yeah, this is the packet that we receive. So the source address should be 1C and ends at F1, and the source IP address is 192.168.1.187. So this is what we should receive. So let's save it, and this time let's run a script too. So yeah, in here you see that the IP address is 187. We receive the IP address and we receive its MAC address. So we have refined the information that we receive. You are not getting all that information because we don't need that. So this is all we need. And just to recap, guys, the the first thing that we do, if you haven't watched the first part of this tutorial, I'll quickly explain it. We need this escapee module that you are importing. This creates the ARP request. The ARP request has the IP address of the target, which is 192.168.187. Then this is the Ethernet frame. The Ethernet frame is FF. This is the broadcast address. We are sending it to all the nodes in the network. And in here, we are combining the ARP request with the Ethernet frame. In here, what we are doing is we are sending the packet that we created, which includes the ARP request and the Ethernet frame. The timeout is 1. It says that to move on after 1 second fails, and the verbosity is false because we don't want too much information. Then we go through the sent and received packets, and we print it. We print the IP address and the MAC address of the node computer. So this is it for this one, guys. If you have any questions, please leave it in the comment section below, and please do like and subscribe to my channel. Thank you, guys. I will see you guys in the next one. Hi YouTube, welcome to the third part of the Python network scanner series. In this tutorial, we'll bring further improvements in this script, and I will show you guys how to import the ARP parse module, and this will allow us to take the target IP address from the user, so we don't have to hard code the target IP address in the code. By using the ARP parse, we can take the IP address in the user as the user argument when the program is executed. It will be easy, a lot easier. We don't have to bring changes in the script every time we want to scan a new IP address. But before we get started, I got a couple of questions from the previous tutorial, which I will answer in the at the last part of this tutorial, if I remember. Hopefully I will remember that. So the question one was, can you explain the FFF part in here, this, the Ethernet? And the other one was that, what is the difference between the ARP packet and the Ethernet frame? So yeah, I will explain that at the end of this tutorial. So let's get started. Now the first thing that you have to do is we have to import the ARP parse module. So we say import ARP parse. Once we have done that, then this piece of code here, we have to put it in a function. So let's call this function scan, and this scan will take an argument, the scan function. So let's put it instead in the code. So in here, now we don't need to hard code the IP address. We just have to pass an IP. So the IP address that we pass to the scan function, in here we are sending it as the packet destination or packet destination. So this is our function. Now in order to use this function, we need a main function. The main function is where our program execution starts and this script is executed. So let's quickly create this main function. Sorry, this is the main function. Now the first thing that we have to do is we have to use the ARP parse module, and we have to create an argument parser. And so let's do that. We will give it the name parser. We can give it any name we want. I've used parser, so let's create the argument parser. So ARP parse dot argument parser. We will also give it a description. I think it's optional. You don't have to do it, but let's give it a description. This description, we will give it something like a simple Python network ARP scanner, or something like that. The next thing that we have to do after that is we have to next thing we have to do is we have to add a positional argument. The argument, in our case, the argument would be the IP address that we will take from the user target IP address. So for that, let's add the argument. So this is the parser that we have created, and for that we will create an argument. The argument would be the IP, and let's give a description for that as well. It will be the IP address of the target host. So it will take the IP address. Now that we have created the argument parser, the argument, and now we have to parse those arguments. So let's call it args, and let's parse those arguments using the parse args. Now that we have done this, Now that we have taken the parsed this IP argument, next thing we have to do is we have to call the scan function. So we call in the scan function, and we have to pass in the IP argument in here. So call in the args, and we pass in the IP address. Just a quick overview. In here we have imported the ARP parse module. This line here, it creates the argument parser. In here we are taking the arguments. In this case, we just need one argument, the IP address. This parses those arguments, and in here we have passed the IP argument to the scan function. The scan function takes the IP address and it passes to the PDST part of the ARP packet. Now there's another question I had gotten about this asterisk here. What it means, the asterisk, it imports everything from the skippy.all module. Now the pro or the advantage of using this is that it can be very convenient when you need money or all the elements from a module. In this case, I'm using the ARP, Ether, and also SRP, these three classes and functions. So it's kind of handy, but you don't have to do that. You can also import specific classes or functions. So in this case, as I said, I'm using the ARP class, the Ether class, and the SRP function. The ARP class is used to create the ARP packet, the Ether class is used to create the Ethernet frame, and the SRP is used to send and receive the packets. So we can also do this: ARP, Ether, and SRP. So now we have imported all these three things, the ARP and Ether classes, and also the SRP function. So this is also one way to do it. So we can save it. Let's go to the terminal. Sudo, we have to so now that we have the parser, we have used ARP parse. What we can do is using the -- help. Let me pull this up a bit. So in here you can see that it says a simple Python network ARP scanner. This is this part of our function, the argument parser. So it gives a simple description of what the parser is used for, and the positional arguments. In here we can see that it takes one argument, IP, and its IP address of the target host. In here it says that the positional argument, which in this case it's the IP address, and it takes the IP address of the target host. This is the description. This is the description of the help section of the positional argument. It explains what do you need to pass in. So again, this time let's pass in the target. I believe it was 192.168.1.187. So let's run this. In here we can see that it has run that, and it has given the MAC address. The MAC address of this IP address, the host that is running this IP address, that's using this IP address of 192.168.1.187. Now, yes, so I received also a couple of questions from the previous tutorial. The first one was, can you explain the FF section, this part, what does it do? Now, the address that we have here, the FF, it's an the address is an Ethernet frame. It represents a broadcast MAC address. So when a frame is sent with this destination MAC address, it signals that the frame is meant to be received by all devices on the local network segment. This is commonly used for protocols like ARP, where a device broadcasts a request to find the MAC address corresponding to a specific IP address. All devices on the local network receive and process the broadcast frame, but only the intended recipient with a matching IP address will reply. As we saw, the first request, I believe it was who is, and then the second was is at. Only that particular IP address will respond with MAC address. And the second one was the second question was, what is the difference between ARP and Ether? So an ARP packet is used to map an IP address to a MAC address, so devices on the same network can communicate. It's like a helper message that says, who has this IP address? Tell me your MAC address. On the other hand, an Ethernet frame is the data packet that actually transports information between devices at the data link layer. It wraps the ARP packet for any other network packet, along with the MAC addresses and control information, enabling devices on a network to recognize and process it for further transmission or delivery. So this is it for this tutorial, guys. In this tutorial, we saw how to take an argument from the user and pass it to the scan function and get the MAC address of the target. So this is it for this one, guys. If you have any further questions, please leave it in the comment section below, and please do like, share, and subscribe. Thank you very much. Hi YouTube, welcome to the part 4 of the Python Network ARP Scanner series. In this tutorial, I will show you guys how to get the interface name from the command prompt. So it will take the interface name, it will find using regular expressions, it will retrieve the IP address. Then using that IP address, we will scan the network for all the nodes or hosts. So by this point, what we have learned is that we can just pass in a single IP address and it will check if that host exists on the network or not. This tutorial, we will see how we can pass the interface, our network interface, and the script will scan for all the hosts that are live or active in our network. So let's get started. So if we go to terminal here, and I use the command IP address show ETH0, you can see that it shows my IP address, just 192.168.192. Now what we have to do is we have to write a function that will run this command for us, IP address show ETH0, retrieve this IP address from this part here and pass it to the scan function. So let's do that. In here, let's create a new function. The name of the function, you can say get IP address. It will take an argument. The argument will be the interface name. After that, let's run the command. So what command do you want to run? You want it to run the IP address show interface name. So let's create a variable. The variable will name it result. And how do we run this command? In order to run that, we need to use sub process. So first, by the way, what we have to do is let's import. For this, we need to import sub process. So once we did that here, the next thing we have to do is we have to run it. So what do we want to run? We want to run the IP address show. So we can type in IP address show, and the last part we will type in the interface. So we take the interface, we pass it here. And the next thing that you have to do is let's type in capture output. We will set it to true, and the text we will also set that to true. So if you want more information about this, just put it in the comment section below and I will answer your questions. Next, we have to define the regular expression. So the regular expression, so if we run this command, we will get all the output that I showed you guys. So what we want is we want just the specific IP address, that part alone. So for that, we need a we need to create a regular expression. So regex, we will call it. So yeah, first we have to import it. Import RE. So we need to import the RE module for this. Then we have to create the regular expression. I will type it now here for you guys. So this is the regular expression. The regular expression. Again, if you need further information about this, it can be kind of regular expressions can be kind of complicated, but this part in here, what it will do is that it will retrieve the IP address, and it will, using this IP address, we will pass it to the scan function here. So previously what we did, we passed in the IP address directly. This time we retrieve the IP address from the regular expression and we will pass it to the scan function. Again, if you need more information about this regular expression, just type it in the comment section below, and I would create another tutorial for this if you guys want it. So next what we have to do is, let's see if we have to search for the regular expression. We see if that the IP address exists or not. So what we do is type in RE search. For this, the first parameter it will take is the regular expression. So we say look for this regular expression. Look for it where in the output of the result command. So the RE search, it uses the regular expression to search. This is our regular expression, the first parameter in here. It will use this regular expression and it will search the output of result. So it takes the standard output, the output of the result command in here. So it can be any command you want. It will look for the regular expression, and if find it, it will assign it to match. So next what we have to do is we have to see if it is true. If the command is run successfully and the IP address is found, we want to return it. So we say return match group 1. It returns the IP address. If it's not successful, then we print none. So we don't want to return anything. Again, if you guys any question about this, if you want more information about this regular expression, it can take some time for me if I go and do a deep dive into the regular expression. So if you guys understand it, that's good. If you don't, please leave a comment and leave a comment in the comment section below, and I will create a new tutorial explaining how this function works. I will do a deep dive on this. So next what we have to do, next let's use our function. So we have to bring some changes to this function here. So instead of taking the IP address, this time we will be taking the interface name. So we can say, let's change the description, the help section also. We can type in something like interface name. So the next thing that we have to do is let's assign it to IP. So we use this function here, get IP address, get IP address. The argument it takes is the interface. So it's our parser args.interface. So args in here parses the arguments, and interface is the first parameter that we pass to the when we are running the script. So once we do that, it gets assigned to IP. We can also do a quick print statement. We can say your IP address is, we can then say IP, and then for the scan, this time we just pass it the IP address. So the IP address that we received from here, we just pass it to the scan function. So let's save it. Let's quickly run this script and see how it works. So let's run sudo python 3 for eth0. So again, let's do quickly a help section. You have to type in the password. So in here, we can say that this time it asks for the interface name, pass in the interface. Let's see what happens. The interface for me, it's eth0. For you guys, it can be something else. Type in the interface name. So you can see that it shows the IP address. It says that this is your IP address, and it searches the network for the host. So far, my script has been able to detect one host. If there are more than one host on your network, the script will be able to detect those hosts as well. So you can just run it again, check if there are more hosts. It will be able to find all those hosts. In here you can see that it was able to find another host in here. So our final goal is to create a script that will run every 60 seconds or every 30 seconds. You can define the time period, and it will continuously monitor the network. It will send this ARP request to find the newly discovered or the new networks, new hosts connecting to the network. So this is it for this one, guys. Please do like, share, and subscribe to my channel. And if you have any question, put it in the comments section below, and I'll see you guys in the next one. Hi YouTube, welcome to the part 5 of the Python network ARP Scanner tutorial series. In this tutorial, I'll show you guys how to add some exception handling. So this code here, it works, but the problem with this code is that if we encounter some error running this IP address command and also what happens if you pass in an interface name that doesn't exist, these problems, how to handle it, we will see in this situation, in this tutorial. Let's just quickly run this again. So previously we typed in this Python command for the ARP scanner in the last tutorial, and we passed the Ethernet 0. So let's say we pass in Ethernet 1, which this interface, by the way, it doesn't exist. So if we type in the Ethernet 1, we get an error. We don't know what's happening. We don't understand anything from this error. So we don't know that whether the interface name exists or it doesn't exist. This error in here, this is not very informative. So we will, in this tutorial, you'll see how we can get how to introduce exception handling, so we get kind of errors that we can understand. And so the first thing, so the first thing that we have to do, let's just put this code in a we'll just try to put this in a try catch block here in Python. So in here, let's put in a try statement. Okay. Let's try to indent this code. So we are trying this command, and in case something happens, some exception happens, let's catch any error. So we will catch the errors in the except block here. So let's type in except, and then we pass in sub process called process error as E, and let's print. So what do we want to print? We want to print something like failed to get an IP address for interface. We will pass in the interface name here, and then we will return nothing, so we will return none. So in here, what we have done is that it will try to run this command IP address, and if there is an error running this code here, if there's any error, it will catch it, and it will catch the error, and it will print this statement: failed to get an IP address for interface, whatever interface that we pass here. And I think there's one thing else, one more thing that we can do in here in the else statement. We can also say that, let's say the IP address, we weren't able to get the IP address, so let's just add in a print statement here as well. So we can say no IP address found for interface. So in here, let's say the command, it was able to run successfully, but for some reason, maybe the DHCP server wasn't running and the interface card, it wasn't able to retrieve or get an IP address. So in case if this command is able to run successfully and the IP address doesn't exist, then we will print this statement that no IP address was found. But if the command itself is unsuccessful, if the command itself doesn't run, then this catch statement over here, this statement will catch the error, and it will print failed to get an IP address. So this should be it, I think. Let's see from the previous tutorial. So in here we are getting the IP address, so we can say that IP interface. Okay, so what we can do is we can so maybe we can use another if statement here. So we can say that if IP, so if IP is successful, we can say that print your IP address is this, and after that we can use the scan. So yeah, so it tries to retrieve the IP address. This is the IP address that we give, the IP address, then it checks if the IP address exists, then it scans it. It says it gives you the IP address, and if it's not successful, then it will, let's just say, no IP address available for scanning. I think we have done a good job of catching the errors. I'm not sure if you would need this port or not, but so in here, again, one more time, if the command is unsuccessful, this statement here, this will catch it. If there is a problem with the IP address, if the interface is up but there is no IP address, this statement should catch it. And in here, we are again checking for the IP address in case there was some problem with the IP address and we couldn't do scanning, the scan isn't successful, we don't receive an IP address, then it won't be able to run the scan, and we will get this no IP address available for scanning. So this will be it. Let's just quickly run it and see if everything is all right. Sudo. So for ETH1, it doesn't exist. We run it. It will ask us for the password. Let's type in. So in here, you can see that even though in here since the ETH1 IP interface does not exist, it says that no IP address found for ETH1. This is this statement here, guys, because this time the interface command, this one IP address show ETH1, it was run successfully, so there was no need for this exception to be handled and for this statement to catch the error. However, since the command was run successfully, but the interface name, the interface one, ETH1, didn't exist, and we weren't able to retrieve an IP address, it showed us the error that no IP address was found for the interface. And the second statement, no IP address available for scanning, is from this port here. Since we weren't able to get an IP address, it's here that no IP address available for scanning. So this is it for this, guys. Again, I think some of you guys, so I'm just trying to not make this tutorial very long by explaining all this exception handling. In the previous tutorial, I didn't explain this regular expression very well. So again, if you have any questions, please put it in the comment section below. I can answer that question in the comment section below, and I can also create a video, another one at the end of this series, explaining these parts that you have don't understand. So this is it for this one, guys. Please do like, share, and subscribe. And if you have any questions, put it in the comment section below, and I'll see you guys in the next one. Hi YouTube, welcome to the part 6 of the Python Network ARP Scanner series. This is the last part, and in this part we will see how to create a loop, a while loop, that will run this script, let's say every 60 seconds. You can change it to 35 seconds or however many seconds you want it to run. So we will see how to create a script that will run every 60 seconds. It will scan the network, it will send the ARP request, it will print out the list of all the IP addresses that it was able to find on the network, and it will continuously run this every however many seconds you want it. So let's get started. Now for this, the first thing we have to do, let's import the libraries or the modules that we are going to need. So for this, we are going to need one, so we are going to need the time module. So we are going to have to type in time module. And the second thing that we are going to need is the OS module. So in here, okay, so this is what you have to do here. Now this part, we know that it runs the scan. So let's put it in a while loop. So we want a while loop to continuously run. So we have to use the while true here. So what does it mean, while true here? It means that just keep running the tool indefinitely. Now, the problem here is that if it keeps running, it will clutter the screen. So what do we want? We want the screen to be refreshed every time we run this ARP scan. So every however many seconds, let's say every 60 seconds, when this network ARP scanning is done, the screen should be refreshed. We don't want it to clutter the screen, and So for this, we have to use the OS module, that we just imported. So we have to run the command. Now we have to run, now this script, we can run it on network, on a Windows computer, on a Windows system, and we can also run it on a Linux system. Now in Windows, if you want to clear the command prompt, then you have to type in the CLS command. CLS is used to clear the screen. So we can say run CLS if os.name is equal to NT. So if the operating system belongs to the NT family, which is the Windows family, then run the CLS. Otherwise, else we can say that's run the clear. Now in Linux, if you want to clear the screen, then you have to type in the clear command. But for Windows, it's CLS. Next, you are printing the IP address. After that, you're scanning. Now this scan, let's say we want it to run every 30 seconds or every 60 seconds. So this is where we want to sleep. So once this is run, then how many seconds do you want the script to sleep? So if I type in 60 seconds, once this is run, the IP address is retrieved, it will sleep for 60 seconds. Then since this is true, we are using the while true here, this script will run indefinitely. Then after 60 seconds of sleep, it goes to the beginning, it will clear the screen and run the scan, show us the IP addresses, then sleep for 60 seconds, then use the CLS or clear to clear the screen, and then print the IP address, scan, and then sleep. This is how it will work. So let's just quickly, for us, we can do it, let's say maybe 10 seconds, not 5. So we can do it 10 seconds. So what it will do is, for 10 seconds, it will run it, wait for 10 seconds, then run again. So let's go to terminal here. We will type in the interface and it will ask us for the password. So once the password is done, so you can see that it's able to find these MAC addresses on the network. So it will wait for 10 seconds, it will refresh the screen, clear the screen, then run it again. So let's wait for 10 seconds. Yeah, so 10 seconds is up. It was able to find these MAC addresses. So if some computers they get disconnected, it will run it again for 10 seconds and then it will stop it. So in here we can see that this time it was able to find 2 MAC addresses. So this is how it works, guys. In order to stop it, I use Control-C. So this is it, guys. This is the this was the 6th part of this series. This is what we wanted to create. The first section we are importing the modules. This section we are scanning. This section is for the retrieving IP address, and this is the main part where the program gets run. So some people I think had a question of understanding this regular expression part. For this I will create a new tutorial. Hopefully it will come in the next few days. So this is it, guys. This is it for this one. I hope you found it informative, and if you found it useful, please consider subscribing to the channel, and also do like and share it with your friends. And again, if you have any questions, feel free to put it in the comment section below, and I will see you guys in the next one. Hey everyone, in this video I will show you how to create a simple Python script to ping a device on your network using Scapy. With just a few lines of code, we will send an ICMP packet, just like the ping command, to check if a specific IP address is reachable. Perfect for quick network troubleshooting or learning Scapy basics. Let's dive in. So by the end of this tutorial, you will be able to create a simple script like this. This is how the final script would look like. So if we type in Python and ping, so we run the script and we pass in our interface name, which in my case it's the ETH0. We press in, we can see that it will ping each and every single device on the network. So it will take the IP address, our IP address, and using that specific IP address, it will scan the range of IP addresses in that network. So in this case, we can see that it is trying to ping each and every device, first, second, third, fourth, seeing that these are down. So it will check for all the 254 hosts in the network. So whenever it finds a network or a host that is up, it will give the IP address and it show that it's up. For now being, all these devices, they are down. All these IP addresses, they aren't associated with the device yet. So this is how the final product would look like. So let's get started. The first thing that we have to do is we have to import the escapee module. So type in from escapee.all import everything. So importing all modules and functions from the escapee library. It imports all the functions and all the modules from escapee. Next, specify the IP address. So IP address, and we can specify a IP address. In this case, we can say that 190. It defines the target IP address to test for availability. For now being, we are just using a static IP address. As we progress, I will show you how to add more functionality to this script. So this is the first part. We are doing a very simple script. We are doing a very simple script for this first part. As we move further and further in this series, I will show you how to add more functionality to this script. For next, we have to define IP packet. So packet is equal to IP, and DST you can say is equal to IP address, and then ICMP. So it creates an IP packet with a specified destination address. We have specified the destination address here, 192.168.190. The packet is further layered with an ICMP, which is Internet Control Message Protocol header. This is commonly used for ping operations to check if a host is reachable. So first, this is the IP and this is the ICMP. The IP address defines this IP address is the target that we are trying to connect to. Next, we have to, once this packet is formed in here, now we have to send this packet. So response, let's create a response object and type in the packet. So we are trying to send this packet, the packet that we have just formed. Timeout, we will specify 1, and verbosity, we will set it to false. So send the created packet and wait for a response. The SR1 function in here that you see, it sends the packet at layer 3, which is the network layer, and expects a single response. The timeout 1 here, this one that you see, it's this parameter ensures the function will wait for 1 second for a reply. And the verbose here, the verbosity, is we have set it to false. It suppresses additional escapee output for cleaner console logs. Next, we are checking, do we get a response or do we not? So we check for that. If response print IP address is up. So we are checking if a response has been received or not. If a response exists, the target host is reachable, and we print that it's up. Next, let's add an else, and then we print IP address is down. Now, if no response was received within the timeout period, the host is assumed to be down. So let's quickly go over this script. We are importing the escapee library, all the functions and modules. In the next part, we set a target IP, which is 192.168.190. In here, we are creating our packet. It has the IP and the ICMP. The IP specifies the target IP address that we are trying to send an ICMP packet to. Next, is the response. This catches the response. So SR function, it sends the packet, it says the timeout to 1, and we set the verbosity to false. And if we receive a response, we print the IP address, and if we don't get a response, then it will say that it's down. So we have to put this in double quotes as well. Let's quickly run this. So in here you can see that 192, 168, 190, it's up. If it weren't up, let's try another IP address. Let's say 180. Let's run it. What do we get? Do we get a down or not? So we run the script. In here you can see that it says 192, 168, 180. It's down. But unfortunately, we also get this warning. The warning says that the MAC address to reach destination not found using broadcast. Now in the next tutorial, I will show you guys how to filter out this warning message. We don't need this warning message. We just want, is the target IP up or is it down? So in the next tutorial, I will show you how to filter this warning message so that you don't see it. Now, if you have any questions, please put it in the comments section below. And if you found this tutorial useful, please do like, share, and subscribe. Thank you. Hey everyone, welcome to the second part of this tutorial. In this tutorial, I will show you guys how to suppress escapee runtime warnings. So whenever this script tries to ping an IP address that is down, it will show a warning message. So in here, let's quickly take a look. So you can see if you type in, if you run this script, you can see that this 192, 168, 180 host, it's down. So it says it's down, but it also gives us this warning message. So what we want to do for this tutorial is to suppress this logging message, because we don't need this line here. So let's get started on this. Now, in order to do this, we need another module. So we have to import that module. So far, we have been using only the escapee module. In order to suppress this warning message, we have to import the logging module. So importing the logging module to manage the logging messages. So in here, we have this warning message that we want to suppress. Next, let's use this module. So we use the logging get logger escapee runtime. So it's a runtime warning message. So this line that I typed, logging.get logger escapee.runtime set level logging error, it suppresses escapee's runtime warning messages by setting the logging level to error. This prevents cluttering the console with unnecessary warnings. So in here, let's run the same script again. So in here you can see that this time 192, 168, 180, it's down. This time we don't get an error message. So let's change it to an IP address that is up to make sure that that is also good. So in here you can see that the one that's up, it says 192, 168, 190, it's up. So in the previous tutorial, I think some of you guys had some questions about the functions that I'm using here. Now, previously I was asked to explain the IP and the ICMP. So IP, it constructs an IP packet with the destination address, which is IP underscore address, which we define in here. This is the target IP address. So it constructs an IP packet with the destination address. Next, ICMP. ICMP adds an ICMP header to the packet. This is typically used in network diagnostics. After this, we have the SR1. SR1 sends the packet and waits for a single response. Returns none if no response is received. Now the timeout here, the timeout specifies the duration in seconds to wait for a response before considering the host unreachable. Then we have verbose. Verbose controls the level. So in here, let me highlight this for you. Verbose controls the level of escapee's internal logging output. So this is it for this tutorial, guys. If you have any questions, please put it in the comment section below. And if you found this tutorial useful, please do like, share, and subscribe. Thank you. Hey everyone, welcome to the third part of this tutorial. In this tutorial, I will show you guys how to take the IP address, the target that you want to ping, as an argument to the script. So for that, we will be using another Python module called ARP parse. So let's import it. Import ARP parse. Now importing this module will allow us to handle the command line arguments. For now, we have hard-coded the IP address into the script. By the end of this tutorial, we will learn how to pass this target IP address as an argument to the script. So let's get started here. Now the first thing we have to do is we have to put this part of the function here. We have to put this inside of the function, this code in here. So let's create a function and we will call it ping scan. It will take an argument. We will give it IP address. We don't need this anymore. Let's indent it and let's change this to, say, IP address. Next, let's create our argument parser object. So parser is equal to ARP parse dot argument parser. We will give it a description, ping an IP address, or by the end of it we will be pinging a range, so we can say ping an IP address range. So it creates an argument parser object to parse the command line arguments. Next, we have to accept an IP address, so we have to define the IP. Parser dot add underscore argument. We want it to take an IP, so we will name it IP. We can name it anything we want. The type will be str. We will take a string, and for the help, let's type IP address, for example 192.168.1.1, something like this. So it adds a positional argument to accept an IP address from the user. So this is our parser. This is our parser, the first line here, and this will allow us to take a positional argument, which in this case is the IP address. After that, we have to store it. So let's type in args is equal to parser dot parse underscore args. So it parses the arguments, parse the command line arguments, and store them in the args variable. Next, we have to access the IP that we have created here. We are taking an IP address, so once it parses it, then we have to access this IP here. So we can access it by, we can say IP underscore IP adder, and you can say args dot IP. So in here, this part that parses our arguments, and we are taking the IP argument. So args dot IP. So it retrieves the IP address provided by the user from the parsed arguments. Next, this is the function. This is something that I have explained in the first two parts of this tutorial. Next, we have to call our function. So we named our function ping scan, and we have to pass in the IP address. So this IP, it holds it, this IP address, this holds our IP address. So let's save the script and let's run it. Sudo. In here, let's type in help. So you can see that first it says ping an IP address range. It takes it from our parser object here, ping an IP address range. Then it says for the positional arguments IP address, for example this. So in here, this is our positional argument, and this is the description, which is in the help section here. Next, let's run it. So let's run it with 192.168.190. We know that this is up, so it shows up. Let's try a host that is not up. It's 180, it's down. So in here you can see that 192.168.180 is down. One is up and the other one is down. So in this tutorial you learn how to use the ARP parse module to take the target IP address as an argument to the script. So this is it for this one, guys. If you have any questions, please put it in the comment section below. And if you found this tutorial useful, please do like, share and subscribe. Thank you. Hey everyone, welcome to the part 4 of this tutorial. In this tutorial we will see how to use a for loop in this script, and instead of taking the target IP address, we will take the first 3 octets of the IP address, and for the 4th octet we will use a for loop. So let's get started. Now in the previous tutorial I showed you guys this function here. It takes the target IP address and pings it, and here we have called that function. So in this tutorial, what we will do is instead of taking the IP address, we will take the first 3 octets of the IP address. So if this is the IP address 192.168.1.1, the first 3 octets is 192.168.1, and the last octet is 1. So this is the first 3 octets, and this is the last one. This tree we will take from the script, as we will take it as an argument to the script, and the last one we will get it from the for loop. So this is our goal for this tutorial. So instead of taking the IP address, we say we are taking the first octets. Let's change it to first octets. And the ping script, it won't take the IP address. We can use this IP address, but let's change it so that's more clear. So we can say octets. Next, we have to put this part inside a for loop. So let's create our for loop. We can say first for let's say last octet and range. So the range can be from 1 to 254. I have to change it to 254, and then we have to put this inside. Okay, we have to indent this. Okay, so for the last octet, next what we have to do first, we have to create the IP address. So in here previously we took the IP address from the function, but in here we don't need the IP address. First we have to form the IP address. So we can say IP address is equal to, then we have to use the first octets. Now the last octet, so first we have to use the 3 octets, so we can type in, sorry, in here we type in first octets, and then we put a dot, and then the last octet, and in here instead of an IP address, it will take this IP address from here. So you can say IP address. So let me quickly explain it one more time, guys. The first 3 octets we will provide as an argument to the script. The last octet, it will be in the range of 1 to 254. This is what this for loop is for. So let's run this script. So last time we entered the IP address. This time we don't want to enter the full IP address. We just want to enter the first 3 octets. So once we enter the first 3 octets, you can see IP address is not defined. So just a second, guys. So we are creating our IP address. From here we are taking it. Oh yeah, sorry. So in here we are, okay, so we have to type in first octets. So these are the first 3 octets. The first 3 octets that you're taking as an argument, we have to pass it to this function. So yeah, I forgot to do that. Okay, so let's run the script. So you can see that it's scanning 192.168.1.1 first, then it's moving to 192.168.1.2.1.3, that. So it will keep on going this until it reaches, it starts from 1, because we have our for loop starts at 1 and it will end at 254. So in this tutorial we saw how to take the first 3 octets from the argument to the script 192.168.1, and the last octet we saw how to use the for loop to get the last octet. Now in the next tutorial I will show you guys how to use a regular expression. Using that regular expression, we don't have to just type in the first 3 octets. We can type in the IP address, we can type our IP address, and we will use the regular expression to extract these 3 first octets. So that's a good that will be a good practice for you guys to learn regular expression to implement it in your scripts. So this is it for this tutorial, guys. If you have any question, put it in the comment section below, and if you found this tutorial, please do like, share, and subscribe. Thank you. Hey everyone, welcome to the 5th part of this tutorial. In this tutorial we will see how to use a regular expression to extract the first 3 octets of the IP address. Now in the last tutorial I showed you guys how to enter in the first 3 octets of the IP address, and this script will scan the entire network for live hosts. So in this tutorial I will show you how to enter in the full IP address, but this function that I will show you how to create, it will extract the first 3 octets and ignore the 4th one. So let's get started. Now in here, instead of first octets, this time you're getting the IP address. So let's type in IP address and let's create our function. So we will call our function get IP address, get IP address. Once we have done that, then this function will take a parameter. Of course, the parameter will be the IP. Now next we have to do is, so let's create an object and we will store this IP address that we pass in here. So we are storing it in this result object. Next, let's create our regular expression. So our regular expression, let me paste it quickly here. So this is the regular expression. I will explain it in a second. So if you so it will take the first 3 digits of the IP address. So if I type in the IP address of 192.168.1.190, this regular expression, it will take the first 3 digits of this IP address. So the regular expression will take the first 3 digits, be 192.168.1. So 192.168.1, these 3 digits, the first one, the second one, and the third one, and these dots here we see, it will extract the first 3 octets, and it will it will store it in this IP underscore regex object here. Next, what we have to do is let's create another object and we search it. So we are searching IP regex, the first parameter, and result. So this is our regular expression which has been stored in this object. In here we are using the RE module, which I don't think I have imported. Let's import this module here, import RE. So using this search function, we pass in the regular expression, which has been stored in the IP regex object, and where do we want to search, what object do we want to search. So this is the result object here. So we take the IP address, we are storing it in this, and once this IP address has been stored in here in this object, then we will use this regular expression to search for the 3 octets, or to look if it has the 3 octets in this result object here. Now next thing we have to do is we have to check, is it present or not. If it is present, if there is a match, then we have to return it. So we return match.group1, and if it's not present, then we will say return none. So once this is done, guys, next we have to, okay, so now what we have to do is, in here we restore the IP address. Now let's get the first octets. So we say first octets is equal to get IP address. So this is the function that we just created, and we are passing it the IP address object. So this is our function. This is the function we are calling it here, and we're passing it an IP object, and this IP object in our case is the IP address. The IP address will be taken from the command line argument. So this is what we're passing it here. So as soon as we get it from the command line argument, we are passing it to this function, which is the get IP address function. Next, so this part I have explained in the previous tutorial. We create this function. It takes the octets. For the last octet and range, it's scanning it, and if we get a response, it's up, otherwise it's down. So let's quickly run this and see if it works. This is script, so we say 1.1 1.1 here. So yeah, it works. So last time in the previous tutorial we saw how to pass it the first 3 octets, and it will scan the network. This time we saw how to create this 192.168.1, and 192.168 we learned how to pass in the full IP address, which is 192.168.1.1. Now of course it doesn't have to be 1.1. You can pass your own IP address. The whole point of this is that so you could enter in your own IP address. So if we go here to this IP address, show ETH0, so our IP address is 192.168.192. so if we do sudo python 5 ping 192.168.1.192 and enter in the password, in here we can see that when we pass our IP address, it will start scanning the network from the first host, 192.168.1.1, then 192.168.1.2. So this is it for this tutorial, guys. If you have any questions, please put it in the comment section below. And if you found this tutorial useful, please do like, share, and subscribe. Thank you. Hey everyone, welcome to part 6 of this tutorial. In this tutorial, I will show you guys how to take in the interface name instead of the IP address, and we will use a regular expression that will extract the first 3 octets of the IP address once we specify the Ethernet name. So let's just quickly look at this. So in here, if I type in IP address show ETH0, so my network interface name is ETH0, yours can be different. So you want to run this command ETH0 as an argument to our script, and what you want is that our script to take in this IP address, it will look the output, look for the output, it will look for the first 3 octets of the IP address. It will extract it from this output here. So we will be using a regular expression that will only extract this 192.168.1 from this from the output of this command IP address show ETH0. So I'll show you how to run this command and extract only the first 3 octets. So let's get started here. Now for this, the first thing we have to import the module. But before we do this, so in here we are taking an IP address. So this time we won't be taking an IP address. We will be taking the interface name. So we type in interface. So for in here, let's also type in interface name. And instead of IP address, it's interface. And instead of IP address, we will change this to interface as well. Since we change this to interface, we have to change this to interface as well because we are taking the interface. And let's also change this name because we will be storing it in our interface object. So previously we had IP because we are getting an IP. Now we change it to interface because we are getting the interface name. You don't have to change it, but this way the code is more readable. So next, what we have to do is our script here, it takes IP. Let's again change this as well to interface. We wanted to change the interface name, and instead of IP this time we want to run the command that I showed you, IP address show ETH0. So for that we need to import the module, which is subprocess. Next we have to run the command that previously I showed you. So we can run it by using the subprocess module, subprocess.run. Then we have to type in the IP address. So the command was IP address show, and it was ETH0. But since yours can be different, and we want to take it from the command line argument or as an argument to the script, so we have to pass in the interface here. So we type in the interface. Once we do that, then we have to pass in the option capture underscore output is equal to true. Capture output true means that the output of this command, or if there is an error, so the std out and the std should be stored. This is what the capture output means. Next we have to set the text. We are saying text is true. So text is true means that store the result that we get as text, not as bytes. So once we do that, next we have to change in the regular expression. So we will be using a slightly different regular expression. So previously we saw that in here, let's type quickly get here IP address show ETH0. So we can see that this line here starts with INET, and we want to take this 3 first digits. So we are looking for the INET 1, 2, 3 digits. We will take these 3 digits from the output of this command here. Again, if you don't understand this regular expression, guys, please put it in the comment section below, and I will create another video that will explain this regular expression. Now, once we do that, then next we have to search it. So previously we typed in result, it's stored in result, but this time we have to just type in std out because we are searching for the std out. We are searching for this regular expression and the output of this result here, the result object. So I don't think we have to bring any more changes. So in here we have, this is our function. We are calling it here. We are typing the IP address, but we have changed it to interface. So let's change it to interface as well. So interface, let's save it. Let's go to terminal, new terminal, and let's run this. So if we type in Python and we type in our interface name. So previously we typed the IP address. This time we are typing in our interface name, network interface name. So hopefully this time it will start scanning. Yes, so it works, guys. There wasn't an error in the regular expression and the code works just fine. So in here you can see that we typed in this command IP address show. It will extract the first 3 digits of the IP address, and it will start scanning for live host, which is 192.168.1.1, then 1.2 and 1.2.3, and this will keep going on until it reaches all the hosts in the network, all 254. So this is it for this tutorial, guys. If you have any questions, please put it in the comment section below. And if you found this tutorial useful, please do like, share, and subscribe. Thank you. Hey everyone, welcome to part 7 of this tutorial. In this tutorial, I will show you guys how to clean up this code, and we have to add in one more functionality. So let's get started. Now, the first thing that we have to do, guys, is we really don't this part of the code here. Let's bring it and put it into another function. So we don't really need it here. You can just bring it down here, and you can have another function. We can call it main. So for the main function, we can put in our argument parsers down here. We also don't need this first octets here, so we can bring it down, and let's just indent this code. So we have put in our code here, all of it from parser. It takes in the interface name, and it's calling the ping scan function here. We have brought all this down, and we have put it into its own function, which is main. The next thing we have to do is let's call this function the main function. So once we run our script, the main function is called. So let's create the function. Name is equal to underscore main. Then we type in main here. So this part here, guys, once our script runs, this section of the code will be run, and this section, it will call our main function. The main function, it takes in the parses the arguments, and it will parse in the it will take in the interface. It will take the interface name. It will extract the first 3 octets, and then it will pass it to the ping scan function that will run it. So let's quickly do it. So if we type in sudo python 7 eth0, so in here it says that the first octets dot is not defined. Get you mean last octet. So let's quickly take a look at this. So it says the IP address, first octets, and last octet. So in here it's the octets here. First octets. So it scans the network. It takes in the it runs the IP address show command. It takes the interface name, and it starts scanning the host, the network for host one by one, 1, 2, 3, 4, 5, 6. Now the problem with this code, guys, it's that if let's quickly run this script again, and this time we type in an interface that doesn't exist. So we don't have an interface by the name of ETH1 in our network. So you can see that it says none. None is up, none is up, none is up. So in here, just get rid of these two. So let's add in an if statement in here. So what we do is we check for octets. Do we get the 3 octets from the commands, from the output of our command, or do we not? So if we type in an interface name that doesn't exist, like we did here, ETH1, we know that that interface doesn't exist in our system, so it won't extract the three octets of the IP address. So for this, we are checking, does it exist or does it not exist? So we are checking first octets. So if it exists, let's indent this piece of code here. And type in the else. For the else part, we can print something like could not get IP address from the specified interface. So if we save it and we run sudo python this eth0, it should work. So we can see that 192.168.11. Let's do it again with an interface that doesn't exist. So this time it says could not get the IP address from the specified interface. So we have, so if the interface doesn't exist, it runs this the else part of this code, because we weren't successful in finding the specified interface name. So it means that the interface doesn't exist. So this is it for this tutorial, guys. In this tutorial, we saw how to take in the interface name and ping the local network for all the available hosts. So if you have any questions, please put it in the comment section below. And if you found this tutorial useful, please do like, share, and subscribe. Thank you. Hey everyone, welcome to the Python port scanning tutorial. In this tutorial, we will walk through creating a simple Python port scanner that scans multiple target IP addresses for open ports. This script uses the socket and ARP parse libraries to enable scanning for multiple ports on multiple hosts, making it a useful tool for network administrators and cybersecurity enthusiasts. So what we will learn in this video, you will learn how to parse command line arguments with ARP parse to specify target IPs and ports, how to use the socket library to attempt connections to each port on each target IP, how to handle errors and timeouts during the scanning process, and how to interpret the results and identify which ports are open or closed. So I'll give you guys a quick demo of how the final script will look like and its functionalities. So I've created the script. If we run it, the script will take the target IP addresses. In here I have specified 3 IP addresses: 192, 168, 190, 191, and 192. And it will take a range of ports, which in this case I have used 8000, 8001, 8002, then 9000, 9001, and 9002. So if we run this, it will attempt to check whether these ports are open on these IP addresses or not. So in the first section, you can see that on the 192, 168, 190, it was checking for all these 6 ports: 8000, 8001, 8002, 9000, 9001, 9002. So this target IP address of 192, 168, 190, it has 2 ports open, which is 8001 and 8002. And this target, which is 192, 168, 192, it has 1 port open, which is port 9000. This the other IP address, which is 192, 168, 191, it doesn't have any of these ports open. So this is how our script will look like once we are done. So let's get started. The first thing that you have to do is you have to import the socket module. So let's import this. Then we have to specify our target IP address. So we can say target. We create an object. It will hold our IP address. We can say 190. And for the port, we can say, let's say, port 8001. Next, we have to create a socket object. So let's create our socket object. Let's type in. So I'll quickly explain what this code in here, what it does. So what is a socket? A socket is an endpoint for sending or receiving data across a computer network. When 2 computers communicate over a network, each uses a socket to send and receive data. A socket is defined by the combination of an IP address and a port number. The socket module in Python provides a way to interact with network protocols. It allows you to create and work with network connections using sockets. The socket.socket in here that we are using, the socket.socket function is used to create a new socket object in Python. This function takes 2 parameters that define the address family and the socket type for the socket that you're creating. Now the first part in here, I'm using AF INET. So the AF INET stands for Address Family IPv4. It means the socket will communicate using the IPv4 protocol, which is the most common version of the Internet protocol. If you wanted to use IPv6 addresses instead, you would use AF_INET6 as the address family. This defines the socket type, which specifies the communication method the socket will use. Next, we are using socket.sock_stream. So sock_stream refers to the TCP, Transmission Control Protocol, which is a connection-oriented protocol. It ensures reliable, ordered, and error-checked delivery of data between applications running on hosts in a network. TCP is used for applications that require reliable bidirectional communication, such as web browsers, file transfers, email, etc. In TCP communication, a connection must be established before data can be sent, and data is guaranteed to be delivered in the correct order without loss. If you wanted to use UDP, which stands for User Datagram Protocol instead, which is a connection-less and less reliable protocol, you would use sock_dgram instead of sock_stream. Next, we have to set a timeout. So let's set the timeout s.timeout. We will put in 2 here. So the s.setTimeout.2, it sets a timeout for the connection attempt. SetTimeout is a method provided by the socket object in Python's socket module. It is used to specify a timeout for socket operations, such as connecting to a remote server or receiving data. This method takes a single argument, a timeout value in seconds, which can be a float for fractional seconds or an integer for whole seconds, which in this case we are using an integer 2. If the socket operation like connect, receive, and send, which we'll see later, doesn't complete within the specified timeout period, a socket timeout exception is raised. So next, let's try a try except block, which catches socket errors and prints an appropriate message if there is a problem at the code. So let's create our try except block. So we can say try. Next, we have to create connect. So use the connect X. So connect X. Then we have to specify the target IP and port. So we have already created objects for the target IP and port. So the connect X method that I am using here, the connect X, it's a method of the socket object in Python. It is similar to connect, but with an important difference. So instead of connect X, we can also use connect, but we will be using connect X. So connect will block. It will wait until a connection is established or an error occurs. Connect X, which we are using on the other hand, it does not block in the same way and instead returns an error code, an integer, instead of raising an exception if an error occurs during the connection attempt. The connect X method, instead of raising an exception on error, returns an error code. It is non-blocking and won't raise an exception, making it more convenient when you want to handle errors in a more controlled way without using try except blocks. It returns 0 if the connection is successful, and a non-zero error code if the connection attempt fails. This makes it easier to check the result of a connection attempt and handle it accordingly. So let's see. Let's try Let's click an if else statement. So we say if result is equal to 0, then we want to print port. So we are taking the port from the port object that we created earlier, and then we can say is open on, then we have to specify the target IP. Else, if our result code is not equal to 0, then we can say print port, the port number is closed on, we have to specify the target IP. Next, let's create the except part here. So I can say next, if there is a socket error, then we have to print that as well. So we can say error connecting to, then we have to say target IP, and we have to specify the error. Now the except, why do we need the except block? The purpose of the except keyword is used to define a block of code that will be executed if an exception is raised during the execution of the code inside the try block. How it works: if an error occurs in the try block, Python will stop executing the remaining code in the try block and will jump to the corresponding except block. If the error matches the type specified in the except clause, the code in the except block will be executed. And if no error occurs in the except block, it is skipped. Now inside the except block, we are using the socket error here. Now except block socket.error. The purpose of the socket error is that this is a specific exception type that is defined in the socket module. Socket.error is the base class for all exceptions related to socket operations. It is raised when an error occurs during the execution of a socket-related operation, like connecting to a server, sending data, receiving data, etc. Now, common causes, some common scenarios where socket.error might be raised include connection issues, trying to connect to a remote host that is unreachable or refusing connections, or timeouts if a socket operation takes too long and exceeds a set timeout period, or invalid operations, trying to perform socket operations with invalid arguments, for example, trying to bind to an invalid address or port, or maybe resource issues if the system runs out of available sockets or resources. Next, for the finally, we have to, we can say finally s.close. So if everything goes well, we want to close the socket. So close is a method of the socket object in Python's socket module. It is used to close the socket, releasing any system resources associated with it. Closing a socket is an important step to ensure that no further operations can be performed on that socket and that all the resources like file descriptors or network buffers are properly freed. Why close a socket? So why should we close it? Resource management. This can be one reason. So operating systems, they allocate system resources such as file descriptors to each socket that is created. If a socket is not closed properly, these resources might not be released, potentially causing resource leaks, which could eventually exhaust the available resources, leading to errors or performance issues, or preventing errors. So once a socket is closed, no further communication can be performed on it. For example, you can't send or receive data after closing the socket. This is useful when you're done with network communication and want to ensure that the socket is properly terminated. Graceful shutdown. Closing the socket ensures that any data buffered for transmission is flashed or sent, and the connection is terminated gracefully. So this is especially important in client-server communication using protocols like TCP. So after we are done with this, let's see if the script is saved. So let's quickly run this. So we can say Python scan, we can run it. So we get an error, non-type object is not callable. So let's quickly look at this. 192.168, what is the error here? So we are defining our port. Next we are creating our socket, socket.socket, and we are setting the timeout. Inside the try block, we are connecting to the target. Then we are checking for the result. If result is equal to 0, then we are searching for the error connecting to. And finally, so in here we are getting an error. So it says on line 8. So on line 8 is our timeout. Non-type object is not callable. Okay, this is correct. So it's not timeout, it's set timeout. So we have to, I forgot to type in the set, so let's quickly run it again. So in here you can see that on 192.168.190, port 8001, it is open. So if we try another port, let's say port number 10,001, and we run this, so if you run it here, you can see that port 10,001, it is closed. So it says port 10,001, it is closed. So this is it for this tutorial, guys. In the next tutorial, I will show you guys how to use the ARP parse module to take the target IP address which we want to scan. We want to take it from the command line argument. So we want to pass the target as an argument to the script here. So let's say we want to scan 192.190. So we want to pass it to the script like this. In the next tutorial, I will show you how to use the ARP parse module to pass the target IP address to the script. So if you have any questions, put it in the comment section below. And if you found this tutorial useful, please do like, share, and subscribe. Thank you. Hey everyone, welcome to part 2 of the Python network scanner tutorial. In this tutorial, I will show you guys how to use the ARP parse module to take the target IP address and the port number as an argument to the script. So let's get started. The first thing that we have to do is import the ARP parse module. So let's import it. Once we have imported the module, then we have to start or set up the argument parsing. So let's create our parser object. So we can say parser arc parse dot argument parser, and then give it a description. The description, we can say scan a specific port on a target IP address. So the ARP parse module is a standard Python library used for parsing the command line arguments. It makes it easy to write user-friendly command line interface and helps you handle arguments passed to your script when it's run from the terminal. It provides an easy way to define the expected arguments for a script and parse them into usable Python objects. This is commonly used for creating tools and utilities that are run from the command line. The argument parser class in here that we can see, this one, it's an argument parser. It's a class in the ARP parse module that is used to create an argument parser object. The parser is responsible for reading the command line arguments, validating them, and converting them into a format that your program can work with. Argument parser is typically the first step in setting up command line argument parsing. The object you create will manage all of the command line arguments you define later on in your script. The description, this is a keyword argument passed to the argument parser. We're talking about the description. It's passed to the argument parser constructor to provide a description of what the program does. The description will be displayed when the user runs the script with the h or dash help option. It is a short human readable string that explains the purpose or functionality of the program. When you run the script with the h or dash help option, ARP parse will print out the description along with other details like the available arguments, their types, and usage. So next, let's add the arguments. So we can say parser dot add underscore argument. So we will provide two arguments. The first one will be the target IP. We will specify a type for it, and for the help we can say something like target IP address scan. Next, let's create another argument. This one will take in the port, so we can say port, and for the type this will also be str, and for the help we type in port number to scan. So parser.add underscore argument. The purpose of this method is used to define a command line argument that the script will accept when it is run. It tells ARP parse what kind of argument the program expects, how it should be processed, and what information should be displayed in the help message. In the earlier code provided, parser it's an instance of the argument parser class from the ARP parse module. Add argument is a method used on this argument parser object to specify the details of the arguments that the program will accept from the command line. Now, for the first one, we specified the target IP, and for the second one, we have specified the port number. So it's ports or target IP, it's the name of the argument that's being defined. This is the positional argument that the user will provide when running the script. In this case, the arguments represent the target IP or the port that will be scanned. The user will need to specify which ports they want the script to check. Next, we have specified the type, and the type is str, which stands for string. So str, the type of argument, specifies the data type that the argument or that the command line argument should be converted to. In this case, the type is str, which is string, meaning that the value provided by the user will be treated as a string. So why string? The user will input a comma separated, as we saw in the first tutorial, a comma separated list of ports. And as a string, the input can easily be parsed and split into individual components later in the script. If you are scanning a single port or a numeric value, integer or int could be used as the type, but here str allows flexibility in representing multiple ports in a list-like format as a string. Then we have help here. So the help, it's a help message. The help argument is an optional argument string. It describes what this argument does, what it is for. This text will be displayed in the help message when the user runs this script with the h or the -- help option. I'll show you guys in a few seconds how that works. Next, we have to parse the command line arguments that are being passed. So in order to parse them, we have to first create it. So I would say args. We have to create args on object. We'll call it args. Then we will create a parser, which is parse underscore args. So once we do that, then the target IP address and target port. So this time we don't have to hard code the target IP address. We can take it from our parser. So we can say args dot target IP. So args is the parser that we created, and target IP is what you will take as a positional argument when we run this script. Next, we have to specify the ports. So args is our parser, and we take port as a positional argument. So let's save it. Let's quickly come here, type in 2. So if you can type in -h, we can see that scan a specific port on a target IP address. So you can change it to IP address. This is this part here, guys. Scan a specific port on a target IP address, and then we have to help commands here for the positional arguments, target IP address to scan and port numbers to scan. So we can say target IP and port, target IP address to scan and port number to scan. So these are the places where the help section and the description comes into play. So let's quickly run this. So we can say Python 3 02, and then we can specify the IP. So we can say 190, and we can say 8000. Again, str object cannot be interpreted as an integer. So again, this time when we are trying to run this, it is saying it cannot be done that. So for this, my apologies, we have to change this to int. So in here, so I could quickly show you guys the port number in here. It was str. In here on line 17, which the error displayed. In here we are using port number. The port number in here. So let's quickly run this again this time. So we can see that it says port 8000 is open. So let's type in port something like 8121. In here this port is closed. So it says port 8121 is closed on 192.168.119. So this is it for this tutorial, guys. In the next tutorial, we will see how to take a range of ports. So for now, I can only scan one port number. So in case we want to scan multiple ports, how do we do that? So that's something that we will see in the next tutorial. And we have to also add in another functionality so that we could add in multiple target IP address. For now being, I can only target a single port on a single target IP. So guys, if you have any questions, please put it in the comment section below. And if you found this tutorial useful, please do like, share, and subscribe. Thank you. Hey everyone, welcome to part 3 of the Python network scanner tutorial. In this tutorial, we will see how to take in multiple ports to scan. So in the previous tutorial, we saw how to take a single IP address and a single port number to scan. In this tutorial, we will see how to take multiple port numbers as an input to the script. Then we will scan, go and iterate over each and every single port, and we will scan each and every one of them. So the first thing that we have to do in here, we have to change the type of this. So we will be changing integer from integer to str, string. Next, we have to, since we will be receiving not one port but multiple ports, let's change it from port to ports. Let's change the object here as well. So how will we be passing the port numbers? So let's say we want to scan ports 9000, 9001, and 9002. So this is how we will pass the port numbers to the script using comma separated values. So we have to split it. We have to split these port numbers using the commas. So how do we do that? We can say args.ports.split. Split using what? The commas, since we are passing in our port numbers in a comma separated here. So we have to get rid of these commas, and we have to split them using these comma values. So we get 9000, 9001, 9002, and we will put this in our list. Without this, we don't need the commas. So once we have done that, next what we have to do is let's create a list, so an empty list. So we can call it list of ports. So list of ports, guys, it's an empty list for now, being doesn't have anything. So once we iterate over these port numbers, we will be stripping the white spaces and we will be converting them to integers because we have changed it to str. So we will change it back to integer and then we will append it to this list. So we have to iterate over the ports that we will be receiving as a command line argument. So we say for port and ports. So for whatever port that we receive, let's first clean it. So we will say clean port and we will say port dot strip. So what will it do? Port dot strip will remove any leading or trailing white spaces. So let's say, let's quickly see this. So let's say our port numbers that we are passing, it has a leading white space like we have in here, or it has a leading white space and also a trailing white space. So a split that we are the strip that we are using here, it will strip the white spaces. So it will get rid of the white spaces and the leading and the trailing white spaces. Once we have done that, next we have to convert it into an integer. So next we can say port number, then we can say integer clean port. So we are converting this port number into an integer and we are saving into a new object called port number. Next we have to append this port into the append this port into our list. So our list is here, it's list of ports in here. So currently it's empty. So what we have to do next is we have to append it. So list of ports dot append. So we want to append what? You want to append the port number. So as we go over each port number, we are stripping the leading and trailing white spaces. We are converting it into an integer and then we are appending it to our ports. Okay, so this is done here, this part. We are done with this part. So once we do that, we have appended all the ports into our list here. Next, what we have to do is let's put this port in here into a function. So let's quickly create a function. So we will call our function scan port. So for the scan port, our scan port function will take two arguments. It will take an IP address and a port number. So let's indent this code. In here we are connecting, so it takes the target IP and port. So we have to change it to whatever we receive in here. So we can change it IP. So this is the IP. Next, the port, it's the same, the port number. So our function will take an IP address and a port. After taking in the IP address, it will scan it. I've already explained this part. So next we have to iterate over the list of ports in here. So we have appended and all of whatever port that we pass into the script, it will be stored in this list. So we have to iterate over this list. So we can say for port in list of ports. After we go over each one of these ports, we are passing it to our function. So our function is called scan port, and we say for this, the first one will be the target IP and the second one will be port that we are going over. So we go over each port and then we are passing it to our script. The target IP is being taken from the command line argument. So let's quickly run this. So we can say Python tree, let's run that. So if we can say 192.168.192. So instead of scanning one port, let's say we want to scan 9000, 9001, and 9002. So all these three. So once we have run over that, so we can see that in here 192.168.192. In here, the port 9000, it's open. 9001 and 9002, these two ports, these are closed. So out of these three ports, only the first one, 9001, is open. So this is it for this tutorial, guys. In the next tutorial, you will see how to scan multiple IPs instead of one IP. So if you have any question, please put it in the comment section below. And if you found this tutorial useful, please do like, share, and subscribe. Thank you. Hey everyone, Welcome to part 4 of the Python network scanner tutorial. In this tutorial, we will see how to take multiple target IPs from the command line argument. And in the previous tutorial, we saw how to take multiple port numbers. But in the previous tutorial, we saw that we could only target one specific IP address. So in this tutorial, we will see how to take multiple IP address as target. So let's get started. Now the first thing that we have to do is, instead of saying you are getting a target IP, so we are getting target IPs. So let's change this, target IPs and target IPs. Again, we have to split it. We have to split it using the commas, because the target IP addresses will be separated by the commas. So after you're done with that, let's create a list of IPs, and this list initially it is empty, just like the list of ports. Next, let's go over this target IPs. So we can say for IP and target IPs. So for this one, we have to again clean out any leading and trailing spaces. So we can say cleaned IP is equal to IP.strip. So it cleans or clears or deletes, we can say, any white spaces that appear at the beginning or the end of the IP address. Next, we have to append this. So once we have stripped it, we have cleaned the white spaces. The next thing we have to do is, just like in the previous for loop, in here we have added the ports to the list of ports. This time we have to add the IP addresses to the list of IPs. Currently the list is empty, so we can say list of IPs dot append, and for that we can say cleaned IP. So it will append the IPs, the target IP addresses to this list. So once this is done, next, so we have to use our for loop. So for the for loop, this time we have to create another one here. So we can say for IP, and we will get this list of IPs, and let's indent this. Let's save the code. So it will go over all the IP addresses. After going over all the IP addresses, it will go over the port numbers and it will scan it. So let's quickly run this script. So instead of target IP, it's target IPs. Sorry, so in here we can say it's IP. So let's run this. So in here we can say Python tree. We are scanning tree hosts, just like as we saw in the first part of this tutorial: 192.168.190, 192.168.191, 192.168, 192, and this is 4 targets. So 192.168, 193. So you're scanning 4 target IPs, and we are looking for these port numbers like 8000, 8001, 9000, 9001, 9002. So let's run this. Okay. Okay, it says we are getting an error. So what's this error? It says name error, name target IP is not defined. Did you mean target IPs? Yes, we have changed it. So this is the IP here. Let's change it to IP, save it, clear it. Let's run it one more time. So in here we can see that it has scanned this first portion here. This is the 192.168.191. 190 host. Of all the 5 port, it has only one, the 8001 port open. So the second one, 192, 168, 191, all the ports that we wanted to target, 8000, 8001, 9000, 9001, 9002, all of them closed. Next, the third target, which is 192, 168, 192. In here, you can see that only one port, which is port number 9000, it's open. The rest, they are all closed. And 192, 168, 193, all those 5 ports, they are closed. So this is it for this tutorial, guys. That's how you can create a script that can take in multiple IP addresses and multiple ports and scan them. Now this in here, so let me delete this part. So we have created these 2 for loops that goes over the IP addresses and the ports. However, we can simplify this. So we can create a one-liner that will do all this coding for us. So instead of having all these 5-6 lines of code, we can have one line of code and it will do all this functionality, that these lines perform. We can all bring it down to just a simple single line. So that's something that we will see in the next tutorial. If you have any questions, please put it in the comment section below. And if you found this tutorial useful, please do like, share, and subscribe. Thank you. Hey everyone, welcome to part 5 of the Python network scanner tutorial. So in the previous tutorial, we saw how to create this simple script that will take in multiple IP addresses and multiple port numbers, and it will scan to check if those ports are open. Now in this tutorial, we will see how to simplify this code. So these lines of code in here, we can just get rid of them and we can just put them in a single line. So how do we do that? It's very simple. So in here, for the target IPs, let's first start with the target IPs. So what we can do, let's just delete all of this. For the target IPs, we can say IP dot strip, and then we can say for IP n args dot target underscore IPs dot split, and we are splitting by the commas. So it will split the target IPs, it will store them in IP, and it will strip. What it means is that it will remove all the white spaces from the beginning and end of the IP addresses. We can do the same thing with the ports. However, with the ports, we have to also convert it into int. So first we type in int because we want to convert the result into an integer. So we can say port dot strip, and after that we can say for port n args dot ports, and then for after that we can say split, and we are splitting by the comma. So once that we have done this, we really don't need all these lines of code. So next we can say that for IP and list of IPs. So we can say for IP and target IPs, because this is where we're getting our target IPs, and this is where our ports are. So target IPs and ports. So we don't need those lists anymore. So we can create so we can use our objects from here, the target IPs and ports. We don't need those separate lists that we created previously. So let's quickly run this again. Python, let's do this. So instead, this time we're running the script, this one. So in here again, it's scanning all those target IP addresses. So again, for this one, we can see 192, 168, 190. Only one port is open, which is port number 8001. For 192, 168, 191, all ports are closed that we wanted to scan. For 192.168.192, only port 9000 is open. And for the last one, last target, is 192.168.193. All 5 of these ports, 8000, 8001, 9000, 9001, and 9002, all these ports are closed. So this is it for this tutorial, guys. If you have any questions, please put it in the comment section below. And if you found this tutorial useful, please do like, share, and subscribe. Thank you.